Welcome to this video on modern Android app development with Jetpack Compose, brought to you by the Programming Professor. In this video, we'll walk through the key concepts of building Android apps using Jetpack Compose, focusing on composable state and hoisting in the context of a pizza party app. This video will walk you through a series of slides that break down these concepts clearly and concisely, perfect for both beginners and seasoned developers looking to master Jetpack Compose. Let's get started. Jetpack Compose, Composables, Layouts, and State by the Programming Professor. Let's begin with the course outline. We'll start with an introduction to Jetpack Compose, followed by best practices in naming and previewing composable functions. Then we'll dive into layout design with modifiers, input handling, and state management. You'll apply these concepts by building the Pizza Party app. We'll also cover debugging techniques and wrap up with a summary and next steps for your learning journey. Jetpack Compose is Android's modern toolkit for building native UIs using a declarative approach. It replaces traditional XML layouts with Kotlin-based composable functions, allowing you to write less code and create more dynamic interfaces. For example, a simple greeting can be created with a single composable function that displays blue text on the screen. When naming your composables, remember to use Pascal case for functions that return unit, like vacation card. Android Studio's linting tool will alert you to incorrect naming, such as using camel case. To see your UI without running the app, use the @preview annotation. This supports parameters like show background color, and show system UI, giving you a live preview within the IDE. Modifiers are essential for controlling a composable size. You can set the width or height individually using modifier width and modifier height, or specify both using modifier size. This allows you to fine-tune how your UI elements appear on the screen. Let's clarify what a DP is. The DP, or density-independent pixel, ensures consistent sizing across different screen densities. For example, 1 DP is equal to 1 pixel on a medium-density screen, 1.5 pixels on high density, and 2 pixels on extra high density displays. This consistency is crucial for building interfaces that look good on all devices. Some common modifiers include alpha for adjusting transparency, background for setting the background color, border for adding outlines, and padding for spacing. When used together, these modifiers give you precise control over your UI's appearance. For layout design, column and row are the building blocks. A column arranges children vertically, while a row arranges them horizontally. These layout containers let you build structured and flexible user interfaces with ease. To further refine layouts, horizontal alignment and vertical arrangement come into play. These properties control how child elements are aligned and spaced. Compose offers predefined arrangements like space between, space around, and space evenly to help you fine-tune positioning. The box layout allows you to stack elements and precisely position them using the Align modifier. You can also simulate a grid by combining column and row components. This layout type is great for building UIs that require overlapping or exact placement. Now let's talk about user input. Jetpack Compose supports input components like button, TextField, and RadioButton. Events such as onClick and onValueChange trigger callbacks. For example, a text field can be configured to accept number input using the keyboard options parameter. Managing state in Compose is straightforward with remember and mutableStateOf, which preserve values across recompositions. By hoisting state to a parent composable like Pizza Party screen, you make child components stateless and reusable. This is especially useful when passing data between components. Let's take a look at the Pizza Party app. It calculates how many pizzas you need based on the number of people and their hunger level. Components like number field, radio group, and button are used. This app includes inputs for the number of people and hunger level selection using radio buttons. When the user taps the button, the app calculates and displays the total number of pizzas needed in a text composable. This is a great way to showcase state management and event handling in Compose. To start, create a new project in Android Studio with an empty activity. Use the package name com.progprof.pizzaparty and set the minimum SDK to API 24. Be sure to use Kotlin DSL. The next few slides will show you the starter code you'll paste into main activity.kt. The first block of starter code sets up the app structure and theme. It includes basic imports and initializes the Pizza Party theme, where you'll define your UI content. Next, we define a Pizza Party screen composable, set up a column layout, and include placeholders for the number input, hunger level, and result display. This screen is where the core logic of the app will live. We then define supporting composables like number field and prepare to customize the UI. You can see how we begin shaping the screen by combining text and layout components in this early prototype. The number field composable lets users input how many people will attend the pizza party. It uses a text field configured with value, on-value change, label, single line, and a number keyboard type. Don't forget to add necessary imports. Once added to the UI, the number field shows up with a label asking number of people and displays a numeric keyboard, making it user-friendly for mobile input. To collect hunger level input, we use a radio group with options like light, medium, and ravenous. Each option is rendered as a radio button inside a row, and the selectable modifier handles selection logic. The calculate num pizzas function performs the calculation by multiplying the number of people by slices per person, depending on their hunger level. It then divides by slices per pizza and uses ceil to ensure enough pizzas are ordered. Understanding composable state is key. A stateful composable remembers its own data, while a stateless composable relies on its parent to manage the state. In our Pizza Party app, number field and radio group initially manage their own state. To improve reusability, we hoist state to the parent. Hoisting means lifting state variables from child composables to a shared parent, making it easier to coordinate updates between multiple components, like when the button needs both number and hunger inputs. Originally, the number field component used remember internally. After hoisting, it now accepts state and event parameters from its parent, making it stateless and reusable. This change enables the parent composable to control its behavior. In the updated Pizza Party screen, we define state variables for total pizzas and number of people. We then pass these values and their change handlers into the number field component. Likewise, the radio group composable is updated to be stateless. Instead of managing its own selection, it accepts a selected option and on-selected callback. This makes it easier to test, reuse, and reason about. Finally, all state is lifted to Pizza Party screen, which manages both the number of people and the hunger level. This centralized state management allows the Calculate button to read both inputs and trigger the calculation effectively. With hoisted state in place, calling Calculate num pizzas becomes simple. When the button is pressed, it uses the input values to compute and display the total number of pizzas needed. To debug your app, use the log class to output system messages, which appear in the logcat window in Android Studio. You can also use breakpoints with the debugger to inspect variables and see where your code might be going wrong. Stack traces provide details on uncaught exceptions, helping you pinpoint issues. To wrap up, Jetpack Compose simplifies UI development with declarative Kotlin code. By following naming conventions, using modifiers effectively, and leveraging layout components, you can create elegant interfaces. Hoisting state allows for clean, reusable composables, and debugging tools like Logcat help you resolve issues. As next steps, consider exploring advanced topics like configuration changes, view models, and theming to further enhance your Compose skills. Thanks for watching. Let me know in the comments if there are other topics you would like me to talk about. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.